the good news was that Louis Uccellini was in India for these storms, and I kind of like enjoyed talking to him and like saying, "Oh, Louis, you missed it." But anyway, that led to this past winter. So this is actually a new slide. This past winter actually had some interesting numbers, not including Washington Reagan National, which we managed to get almost 10 inches of snow. But it was a good 10 inches.
What was it really? Did you know the airport's number?
It wasn't that much more, I'll tell you that. No. It was basically January 26th, which apparently I'm not talking about. But everywhere from basically New York City on north, I watched. I was envious, but not as envious as I used to be. I still have that sense of satisfaction and knowing that I'd actually lived through something that was good. But that's all done now. And anyway, it's 100 and something degrees. So anyway, we're into some of these fairly impressive records that are being set. And for this is a good one. Highest consecutive two-season totals, both at New York City and Philadelphia, Pennsylvania. That's pretty respectable. 112, 122 inches.
Those temperatures yesterday.
What's that? Maybe I shouldn't be answering things that come from the audience here. But what am I saying? Maybe. I know. But anyway, last winter had some really impressive totals, including my old haunt, Atlanta, Georgia, and that actually was a lot of snow for them. It was really bad. Oklahoma, Chicago had it really good. That blizzard on February 1st was just amazing. Like, okay, even the Midwest can get something good too. And then places off to the Northeast just had a really wonderful winter. And one thing in my book is that I have these listings of storms, and I wrote it at a time where, the 60s looked really good. And now that I'm actually sort of working on what's called a volume 3, I was actually thinking, I know it's hard to see, I was actually thinking how originally that I would include some of the storms at the end of the old book after 2000, because I didn't know if I'd have enough storms to fill up the next edition. Oh, was I wrong? It's really been a very, very spectacular period of time. And these last two winter seasons have been really just enormous. So looking at Boston, there's a list from the 60s. I know you can't see it, but here you can. But since the year 2000, and especially since 2006, there's been an awful lot of storms above 10 inches. The same basically holds true. New York City, 60s were great, but look at 2000 to 2010, and just last winter, 4 storms, over 2 winters, 4 storms, 3 of which around 20 inches of snow. That didn't happen when I was a kid. Philadelphia, I don't know, somebody must be smoking their something when they take measurements, but they got these really big numbers, but it works for them too. And Baltimore, I don't know why they changed it afterwards. They downgraded their second storm in February to 19.5. They had like 26 point something, I think. Where they had some, no, actually it was the 23. But I can't even see it. 25. Really, they had that much? Huh. Oh, that's right. They had like 28.5, and they were going higher.
Right.
Well, then they downgraded.
The airport didn't follow the rules.
Right, but it turns out that the 28.2 in February 2003, they followed the same rules. So they had a lot of snow. And even in lowly DC, which can't measure snow worth too much, we're doing okay. Back in the 60s, there wasn't even one storm greater than 10 inches, and in the last 3 winters, basically last winter, not too bad. So in 2009, 2010, this was the makeup of that winter. And there will be 4 storms that will be in Volume 3, December 2009, the 2 storms in February, as well as the late February 2010. All of those count. And part of the reason for last winter was El Nino, abnormal sea surface temperatures, abnormally warm sea surface temperatures in the Pacific that have the tendency to increase the temperature gradient. It's kind of like a Rube Goldberg thing. One leads to the other, leads to the other. No. You got the storm track increase along the southern stream. And in big El Nino years, we often get mostly rain, except as you go farther into New England. But fortunately, the North Atlantic Oscillation, a pattern across the North Atlantic, set up in such a way that we had a blocking pattern in the Northeast, where it got very cold down into the south, and it was such an extreme version of the NEO that it actually stayed relatively warm up in much of New England. So most of the cold air came south, which was good. When we had that storm track come across the south with all the cold air, it worked. So last winter, basically the NAO was at the lowest level. On the top right-hand side is sort of the daily version of the NAO. It was negative practically the whole season. And if you look on the bottom left of the figure, you'll see that since 1950, that was the lowest value of the NAO averaged over the winter season since that period of time. So I guess one can infer that with a negative NAO, that's not a bad time to be looking for winters with a lot of snowfall. But everybody's really focused on El Nino and La Nina. This past winter, the big focus was on La Nina, so the expectations, most of what I heard, were actually pretty low. So I get to repeat this too, because I like to draw these storms. This is the December storm, which was supposed to be the storm we would remember and remember and remember, because it's the big one. We're not going to get one that's going to be bigger than this. And now it's like, which one was this? So this was the first storm in December. Classic Gulf Coast, if you want to call it a type A storm. Moves up along the southeast coast, big high up over just north of New England. Doesn't move to the east, and the storm then basically wraps up off the mid-Atlantic coast and then drifts slowly eastward. Already did that last year. Here's the snowfall distribution from that guy.
Oh, God, that was good.
Hey, this storm didn't bring any snow to New England, did it?
No. This one actually depends where.
That one
Was. All right, I'm going to sit down. My sister actually lives in Chemung, New Jersey. I'm going to get my sister into this. She lives right here. She did really well. I was excited for her. And this, I really liked. This is why I need to get that last one for the Boxing Day storm. I mean, I don't think I need to really describe what's going here. But I have this for basically all of these storms. And let's just breathe it in. Yeah, it's a good thing I know these people, right? Yeah, not really good at this.
That's the one they use yesterday, push it a little to try.
Oh, there it is. All right. Yeah. I want to see that band set up right there. We go. All right. Still really setting up here. All right, cut across. Oh, there we go. Very nice. Very nice. Oh, there we go. I need a drink.
Give this man a towel.
I know.
Oh, God. What am I getting myself into? And associated with the negative NEO, we had a Greenland block, and this is the absolutely ideal example of a Greenland block in existence. So I said that last year. Let's go on. So how did they forecast? The December storm was, okay. Not great, but the European had actually something 4 days in advance. You know, I do work for NSEP, so I really should be talking about the GFS. No, I'm going to talk about the GFS did a great job, relatively speaking, for the Boxing Day storm. But I do like to give kudos where kudos are due. That was the GFS forecast 4 days out, but eventually the GFS did come about. So 2 days in advance, you know, I mean, 2 days, it's not...
48.
What's that?
48.
Yeah, that's not bad, not bad at all. So we had, you know, some lead time. There weren't any negative stories in the paper, oh, they blew that one. So we did okay. But really, I want to get more into reminiscing about this one. This was like nirvana. And, you know, I know the audience, especially the New Englanders here, you can now really sort of identify with me on this. Because now that you've probably gotten some satisfaction, you can understand the reason why I gloated so much last year. So, let's just breathe this in again. Basically the same type of thing. I know, okay, all right.
My house is where the 4 is and the 24 is, right near the Mason-Dixon line. Keep moving up to the right. Bam, right there.
You like
Those are mostly the weather people.
Loud and counting.
It was wonderful.
For a year, I mean, I can understand why you're having this conference here in Baltimore, because Baltimore was the heaven on earth area that particular winter. Actually, it was north and west. But they?
The white where it's not the most, right?
Oh, yeah, that's it.
Yeah, so there's 5s and 6s and feet.
Okay, we will have silence.
Yeah.
Oh.
Beautiful. Yes.
Oh, wait. Oh, it's building back.
Yeah. Yes.
Oh. This is a good group to talk to.
There are kids here, Paul.
I know. And I'm not going much further. I mean, this one, I think, still just sort of takes the cake. Like, if you wanted to promote where we've come in meteorology, this is the 8-day forecast issued by the European model. Here's the verification. Here is the forecast. Yeah, if you don't think this is very good, it was issued January 28th to verify on February 6th. So, you know, how hard is our job going to be? Anybody remember December 26th?
Now, we didn't talk about this weekend.
We did a little bit. I saw that too. Right. So GFS, no, but eventually GFS. You know, everybody caught on. You know, all of the ensemble forecasts basically, you know, telling us the same answer. This was easy. And, you know, here's the observed on the left versus the forecast. You know, it's not bad. So the impacts, there are states that declared emergencies days in advance. Airlines canceled thousands of flights. They knew that in advance. Stores adjusted. Federal disaster was declared. And, you know, they should all be this easy. And while that storm is going on, you know, the news has always been sort of like, you know, oh, wait till the next one. Well, for the very first time, it's like, there was a next one. Damn. And that's the one. And this one was far more complex. Not one of these simple things that went across the Gulf Coast and moved up the eastern seaboard. But this one still also had a component that developed over the Gulf Coast, but it had a bigger component with a digging trough coming in from the Midwest. Sort of like a little match waiting to set off a fire. So you don't really see it obviously on the surface, but we've got the big high and the ridge extending down the east coast. And then eventually one low pressure develops into the Ohio Valley, and then the second one explodes on the coast. And it's pretty easy, right? Oh.
I don't get 18 inches on that.
Oh, it's...
Three.
Remember, you had this year.
Is that 1 foot at the time?
No,
Those
that's,
are feet.
no, it's one. No. Oh, that's right. The numbers are in inches. The colors. Okay.
Yeah, you might have.
All right. Again, first batch goes up. It's over. Oh boy, what's going on over here? Oh my goodness. And there was rain here, but here goes the bright band.
I had snow drifts on all 4 sides of my house. It's unbelievable.
Have you? I'm going to let it ride
I
again.
know my friends in New England and Glen.
I understand. This is amazing. I just think this is amazing. Yes.
We have our own.
And this is an interesting case because there is a bit of a block near Greenland. There is a short wave coming out of the southwestern United States, but the big factor in this was, of course, the bowling ball that came out of the Midwest. Two of them interacted, and when they hit the coast, boom! It's scientific terminology. So, and here are the 6, 4, 3, 2, and 1 day forecast. 6 days, nah. 4 days, yeah. Now, originally, the snow was originally forecast to be primarily north of the Kocin, Washington, Baltimore area. But actually, as it came down, because that was our winter, we got into that, into the mix. Yeah. So, and then there was the one at the end of February, which, in this very strange winter, New England gets all rain, because the warm air is coming in from the east, and the snow then backs in from the west. We didn't get it in D.C., but from Philly, basically from New York and central New York State. This was something else. Yes, it was a weird storm. You basically started, which looks like not a particularly interesting trough, but it develops a closed low, and then it goes negatively tilted, deepens, and then moves up the coast. We don't get them to do that very often, to have the storm actually retrograde the way this one did. And this will also have a very ooh-ah sort of radar. Not this, no. It's just the snowfall. But this one's sort of the ooh-ah, even though I would have preferred having it farther west. But how often do you see this? Here comes the low. And where I grew up, they managed to get like 14 inches of snow on southwesterly winds. That never, ever happens.
That's awesome.
So,
It's a nice rainstorm.
yeah. And so what happened this past winter? Oh my God.
Yeah, what did happen?
I don't remember. So anyway, I'm going to focus basically on this particular case because I was asked through Louis, through the head of the Weather Service, to write up a report on what actually went right and what went wrong with this case, because there was back and forth on this particular instance. This was going to be a really big project for the Weather Service until there were some tornadoes, a little tsunami, and it's like, did it snow in December? So the report is yet to be finished. But there was, considering the year that we've had, the winter we just came through could have been a real contender I'm going to focus on December 26th, 27th. There was another great event on the 11th to 12th. I saw a good inch out of that. And then there was the high impact event on the 26th, 27th, which even though the Washington area, as you now know, did not get an incredible amount of snow, the timing on that system, it was phenomenal. It was, I'm so glad I didn't drive to it. So glad. All right, so what epitomizes the December 26th case? I think this is really a very good representative picture. The snow did not fall just gently down.
Wow.
This is the day after, and you'll notice not only the cars are in these fabulous shapes, but all of this stuff is just continuing to blow around well after the snow had ended. You know, that just doesn't happen very often. And of course, your standard snowball fight in Times Square. And this was already shown earlier, but we can still show it and appreciate it. Yeah.
The previous picture of the cars, how much of that was from the drifting, how much was from the actual snowfall?
Well, I mean, when you get winds that strong, it's hard to tell. It really is hard to tell. And I would venture to guess, I'm sure most people had no clue, like, how much snow really fell when winds are averaging 30 to 50 miles per hour for hours.
I think most of them look like 24 or 25 though.
It's so hard.
Yeah, it was really hard to tell.
Hello?
All right. And, of course, I've drawn these up. But, you know, some of the analyses shown before, sort of your, not really a classic case, because the big high is sitting over the center of the country. There's no big high over New England. But it managed to do just fine along a very strong baroclinic zone along the East Coast. And between 12Z on the 26th and 0Z on the 27th, it deepened 20 millibars or more. So in order, and then it continued to deepen to about 962 millibars, which is also mentioned. You know, they don't do that very often. And what was sort of interesting, there really wasn't a strong short wave. You really couldn't identify it in the vorticity field. It was more that you could see there was just sort of, and they're talking at Stony Brook and discussing this more in terms of what they call wave packets. It wasn't like a short wave sort of set this thing off. Yes, there was a system in the southern stream, but in the northern stream it was very difficult to sort of pick out this one system that was digging. Sort of a bunch of them, however you wanted to call them, jet stream or whatever, jet streaks. They just all sort of came together. The response in any event was this very strong intensifying cyclone. We got to see this? Yeah, but you know, I mean, as far as like eating crow, this is where I live. You know, and it actually did snow in D.C. for like 10 hours. Just
wow.
very, very lightly. So, here's the HPC 6-day forecast, verifying on the 27th of December. I know who issued the forecast. I'm not going to mention names. He was so condemned because he wasn't following protocol. Which, in the age of ensemble forecasts, you're really looking for various solutions and the more likely solutions. And he decided to just go, well, I just think this is going to happen because that's what I want. And he was excoriated, and that was his forecast. So he wins.
That crazy extra.
No, it wasn't extra.
Was it wrong?
And this is a forecast from December 22nd, where the models are still basically indicating something big. The blue is the actual track of the storm. The red is the GFS forecast, and the green is the European model. Right? Is that right? No, it's reversed. The red is the European, the green is the GFS, which is saying nothing, and the red is going, ooh, big storm mid-Atlantic, nothing farther east. So the fact that we'd originally had some model indications that there was going to be this potential for a major storm, the models after that were really sort of back and forth, and nothing was really quite certain until 0Z on the 24th of December, when they all seemed to come together. Offshore, right. So, and it was really hard because actually our forecasters on the medium range, we don't like to do big changes unless we're more certain. So the forecast was actually keeping it closer to the coast, but you can imagine the consternation of seeing all these operational forecasts and going like, oh my God, what are we going to do? So another bust. Oops. But then, in the next round of model simulations, the GFS is the one that goes, look, the GFS is in green, it goes really close to what actually happened, while the European instead is more farther out to sea. And that actually continued with the European for at least a couple of cycles. And the only ones to get anything really out of that track was east from Aruba. The only problem with the GFS forecast was that it brought the snow back to like 6 to 10 inches in the Washington area when, I was looking at my quarter inch from the whole day. But the GFS was actually the model who sort of caught on earlier. So here's sort of a combination of all the different model runs. Here's 3 days before, and we're buying into it's way offshore. But then 2 days, rather than going with more of the European, following the GFS, the forecast really wasn't all that bad. But I heard from Harvey Leonard at a conference I went to about a month ago that we had a discussion that came out of NSEP that basically said that there was some bad model data that got into the forecast, which we don't know why that got in there because we didn't know what bad model data. So anyway, it turns out that that little forecast where he's talking about the bad model data caused your office not to issue a watch. That's what Harvey was talking about.
Well, they said it was bad initialization.
Bad initialization.
That wasn't the model data itself, it was bad initialization. That's what we got too.
Right, well, that we saw what he sent out. Or he or she sent out. So there were all sorts of problems during this storm. All of them. Models just flip-flopping back and forth. And it turns out I had to work what's called the model diagnostics desk, which has to indicate, it's the forecast desk where we indicate our model preferences for the day, which is becoming a little more irrelevant in the short range because most of the models are actually becoming pretty close. So I'm thinking, I haven't worked this desk for like 6 months. I'm going to get stuck in the mechanics in this horrible storm where it's going back and forth. And I guess I really lucked out because I worked on the 25th, and that morning all the models went together. So, technical term. Brother talk, right. So the reality is our 2-day and 1-day forecast actually started looking fairly good. So the impact with such a back and forth forecast, considering that the forecast really came together on the 25th, storm came together on the 26th, 27th, reality is it's not like it was a totally busted forecast. We've changed because we expect things as shown last year. Oh, we can see it 8 days coming. Most of the time it's a lot less. 2 to 4 days is probably the best we're going to do, at least most of the time. And here comes this storm, like, oh my God, but at least 24 to 36, maybe 48 hours in advance. We had a good idea at that point. So despite the fact that the forecasts really were just awful in our minds, airlines did what they had to do. They're able to cancel a lot of flights. Transportation systems, at least in the airports, were really on target. However, New York City did not declare a snow emergency despite blizzard warnings. And I guess all blizzards are not the same. And their rationale was that, well, we had a storm in 2006, dumped 27 inches of snow. We didn't have to issue a snow emergency there. We did just fine. We had another storm on, let's see, when was the one? Oh, late February 2010. Another one where they did not issue a snow emergency. So they figured with this one, even though it's the same kind of forecast, like, we'll do the same thing. The reality was those two previous storms, totally different kinds of snowstorms. One was a very fluffy snow, it fell on a weekend. The other one was a very wet snow. Most of the first 6 inches didn't even stick on the roads at all. Fell overnight, very wet, and they got it off. This one, 30 to 50 mile per hour winds. The day after Christmas, a lot of people on the roads. It turned out to be a catastrophe. So there's all this trying to understand actually the impacts. Like we have to be able to communicate this better for them to be able to make the decisions that they need to do. And it almost sounds kind of like the same thing with the Joplin tornado, in that if you're issuing a lot of or you're seeing a lot of the same conditions and you're issuing a lot of forecasts that come about in a similar way, you get sort of inured to the real threat of what actually may be happening. So they have these two 20-inch snowstorms in New York that aren't that big a deal. And this one is a third 20-inch that turned out to be a real big deal. So there has to be some way of differentiating, as Mike was talking about. We're not all there and talking about impacts on all these individual storms. So, how do you deal with flip-flopping forecasts? I know probabilistic, sounds real good. I know the public really doesn't understand that, and specifically, but the reality is we have to do a better job in communicating in terms of whether it's not either or. It's either going to be a big storm or no storm, but just being able to communicate that, 4 days in advance, if we're thinking this, it's going to be different than 2 days in advance, because as we're getting closer to the storm, the kinds of conditions we're expecting, our confidence is changing. So, for the Boxing Day storm, we're able to see something for almost the wrong reason 6 days in advance. But, wasn't totally out of the woods. Low confidence about the model predictions, especially until late on the 24th. Blizzard warnings were issued for New York at 4 p.m. on Saturday on the 25th, 14 hours prior to the onset. So it wasn't a surprise snowstorm, but it was a pain in the... So why the difficulties this year? And this I've actually gotten more from Louis, who talks a lot to the CPC, Climate Prediction Center. And, I haven't really looked into this much, but apparently there's a link between El Nino and La Nina as far as predictability. Apparently, and this, again, I'm just sort of relying on his information, when you have an El Nino pattern, southern stream, it's relatively more direct. When you have a La Nina pattern, you have a lot of upstream energy going towards the pole, coming down. It's more difficult to resolve. The models, perhaps, have a harder time resolving that. Maybe that's what we saw. So the difference, this past winter, La Nina, the tendency for La Nina winter has been for not very many big storms, at least in the Northeast. However, NEO was very negative, very negative. So that seemed to override what was going on with La Nina. How are we going to know that? How can we apply that? I don't know yet. I really, have no idea what supersedes something else. How big does it have to be? So with a La Nina event, perhaps it is more difficult to predict with more different shortwaves involved and more difficult to resolve these systems. So then we have the 11th and 12th of January. I got my inch of snow, New York had 9, and New England had lots. So there you can see I'm finally focusing on New England, where I've got my inch. And you can notice that heaviest band, the darkest blues, are over central Connecticut and western Mass. And if we look at the radar for this one, this storm was actually just one of rapid development. And it's developing okay. And watch what happens over western Mass and western Connecticut. Ooh. So we get to see this an awful lot.
Full frontal.
Very nice.
No, wait, we did wear that here once.
Well, guess what? January 26th. School.
I want to get rid of
Right, so I don't have to spend a lot of time on this one. It was for most people a very rapid hitting event. It was for us. I remember the forecast looked like, well, New York, the heaviest precip was going to be to their east, I think. Oops. But that happens sometimes with these big storms, that we often think that the heaviest precip, at least the models are saying heaviest precip, is farther east or farther, it's mostly farther east, and it's actually closer to the outer edge of the precip, where the banding sets up. Pretty good, just pretty good. I think we've already seen this, and this is another ooh-ah.
Okay.
The morning, we had some unpredicted snow. Oops.
Oh.
Then it ended, changed to rain. And then, oh. But wait, it gets even better. Then, that band. I was watching the live Times Square cams that evening, and it was just like, oh my God, what is going on there? They were getting 3 inches an hour for like 6 hours, and that was it. So, 3 major snowstorms in 2009, 2010. I ain't going to see that in a while, unless we get it this winter. The combination of the most significant negative NAO since 1950 and a strong El Nino signal led to heaven on earth. Forecast-wise, the first one was done in 2 to 4 days. Second one, 7 to 8 days. February 9th and 10th was forecast 4 to 5 days. So that gave us some kind of like, okay, in a good year, that's how we can forecast these storms. That's what we are expecting to do. This winter, La Nina had been expected to be dominant. Oops. NEO seemed to have the upper hand, and for basically a 1-month period, New York got 57 inches of snow, Hartford got about 70, Boston had their 8th snowiest winter. And because of these 2 winters, I just kind of add that it just keeps me talking. And we can look back at this period and call these are like the good old days. And that's what I got. I also, thank you. Oh, well, just a second. I'll get you, Kevin, soon. I was supposed to have 2 boxes of books sent here if somebody wanted to buy them. They are $60 a piece, which is a very special rate because I'm selling them. I'm selling them through the American Meteorological Society. Turns out, and they've done this before, they didn't send 2 boxes of books. They've sent 2 volumes of books. So, the good news, I do have 1 buyer, which means I have 1 more left. If anybody is interested, I'll take cash or check.